In the meantime, for those of you who are already here, we are recording the presentation, the session as all the previous session we had in the conference. In this case, however, since it's a public event, we are then passing the registration to Elsevier, and so they will upload the recording of the presentation in their website. So someone is not happy with his solution, is informed, so he or she can do whatever they believe is appropriate. Okay, so maybe a couple of minutes more, we are ready due, and so we can wait a while and then start.
Then normally we would have a chat now and a glass of wine in the hand and just easily start our ceremony.
Yeah, but we are trying to have it.
Yeah, it's a different time.
Yeah. No, actually, I don't know if he's with us now, but a couple of more or less 1 month ago, I was attending a contest organized by Frederic Lorrain and French friends, and they sent everybody a box of French food, and so we had the welcome reception 2.0, 2.0, just toasting a beer and French salami, which was good, but it's a bit complicated from the logistic point of view. Anyway, we were running a survey among the participants, and everybody's happy to have the conference organized next year in presence. So we are working in that direction, so we can avoid the problem of remote. Well, I have to say that there are advantages and disadvantages, because it's much easier for everybody to join the event, but at the same time, what is really missing is the physical contact, the interaction, the social events. And so, you have some always drawbacks and advantages. And so, but we really do hope to be able to get back to the almost normal life as long as we can. I will say that in the last period in Italy, we are 95% back. The number of infection is basically around zero. People start moving. I hope they are not moving too much, because now it's very hot, let's say, and this is also helping the situation. I'm quite curious to see what is happening after the summer, but let's hope that the vaccination program is continuing, so we can really restart at full pace in the original way. Okay, I believe we are already in time. We are about reasonable numbers of people is coming, and so maybe a couple of minutes more, then we can start. The main person here are connected. Carl, you are here. Hing is here.
I'm here, yes.
So we can.
So before you start, but there are already some people listening to us, I want to say that you did a very great job in not only preparing your conference, but aside of that, also preparing this ceremony and being the chairman of the evaluation of the CSTE award. So thank you. That was very great. And now we can do our job.
Part of the business is part of our job, so we have to do it. Thank you anyway for the acknowledgement. Okay, I believe that we can start. I need only to recap the presentation, because without that we are a bit. What is it now? Okay, here we are. Okay, now this is for David, because I saw him, our publisher from the Elsevier. David, we are live on streaming and we are recording the presentation. So
fantastic, great news, Marino. Thanks.
Okay, so we made. Okay. Well, thank you everybody for coming. You know that now we are starting the afternoons, the afternoon session. The last day of the conference. We enjoyed so far. We had a quite tough pace in spite of the fact that we are having the virtual meeting, but I'm sure that I'm a bit tired, so I'm sure that everybody attend all the session can be more or less the same. The difference is that you can be relaxed on your sofa, but you are still hanging on a screen, and so that is also important with your brain connected, and that is quite heavy also. Today we are here for celebrating a young researcher and her achievements. And well, I partially spoiling the results, but you know already. So let me just introduce, well, you know for sure, all Carl Schulte, which is a big another of the best friend I have among the other we mentioned today morning and in the previous days, and as part of the community of Composite, and most of all here is in his position of editor-in-chief of Composite Science Technology. So let me pass him the microphone and the floor, and so we can start the ceremony for the Composite Science Technology Young Researcher Award. I will share the screen, so Carl, you can start, and then just to give you a brief agenda of the talk, Carl will make a brief the winner, and a brief presentation from the scientific point of view on the subject of the award was given. Then we'll have a presentation by the winner, and then I will make the closure. So I will share the screen, and then Carla will pass you the microphone. Here we are. Okay, Carla, the floor is yours.
Yeah, okay. So it's just the introduction. So then I would say we can go to the next slide. Just the next slide, please. Yeah, okay, so that's the reason why we're here. That is the CST Young Researcher Award, and we have this year a winner. So that is Dr. Ying Wang. I just saw her briefly before 5-10 minutes ago. So she is the winner of the 21 CST Outstanding Young Researcher Award. And in the next slide, we will then, yeah, Marino, yeah, I think I cannot do that in the moment, as I see. Can you give the next slide? No? Yeah, no, that one. And so at the very end, it was a tough decision among 14 scientists who were proposed. And Professor Karasimin, he was heading the evaluation committee, and after this tough competition, all agreed that Dr. Wang should receive the award this time. It is the third time that we give the award to a young researcher, and we hope to follow that also into the next future. So Dr. Wang, she received her Bachelor of Engineering in Materials from the Shanghai Jiao Tong University in 2011. And then she made her PhD degree at the University of Manchester under the supervision of Professor Phil Wissers and Kostas Soutis. And as present, she is engaged in a postdoctoral research work on fiber-reinforced composite materials and mainly working on X-ray computer tomography. And from out of this work, there came a couple of presentations. And the next slide, please, Marino. I can't do that. Yeah. And from this presentation, there came out 3 publications, and these 3 publications are the basis for the award-winning. For the award winning, and therefore we congratulate her. As you see, all deal with X-ray computer tomography. And of course, she was also part of another research work that was X-ray computed tomography of polymer composites. And this was a feature article received in already in 2018 in Composite Science and Technology, and it is since then the most downloaded and most cited research work we had. Now, the subject she is working on, and that we want to see here, if we talk to X-ray computed tomography, then it's quite funny. X-ray computed tomography is something which covers a broad band in application or in research dimension. So we can say it is somewhere between micro and structural level. I have plotted here a graph where we see on the left-hand side the nanostructured material and the nanoparticles as well, and all that goes up into a structure. In this case, it would be a wind turbine blade. But what gives now X-ray tomography? And maybe we go back forward now to the next slide. That means in the past, when we wanted to understand damage in a composite material, then we had either to make X-ray photographs, as you see some here, and this X-ray radiograph is from a cross-ply polymer, and in order to see damage, in this case, cracks or internal delamination, something already talked about this morning, then we had to use an opaque or a penetrant or an opaque that penetrated into a damage. And once it was in there, then we could see that in an X-ray. This work, for instance, is done in 1983 together with Chuck Jamieson from Virginia Tech, and we were longing for having a magnification of the X-rays. But in those days, of course, it was not possible. When we now wanted to understand what is inside, then we had to go to scanning electron microscopy. And that is shown in the next slide. So that means we had to damage a part, so that means to bring it to failure, to crack it, and then you see here a failure surface of a delaminated area of a transverse crack. And what we can see here is somehow a crack line, the tip of a crack line that goes from the left to the right, a little bit below, and then you can see near the tip of this crack line, there we could see fiber fracture, but that there occurs a fiber fracture, we could only see after a total damage. Or the next slide showing that is that we made a deploy technique. That means we burned off the matrix and then we could see the naked fibers. Yes, leave it here. And also that we could see. So that means to get an understanding of that, what's going on, we had to destroy it. And therefore we had really a damage evaluation was rather difficult and rather painful. Now with a new technique, which we have available, X-ray computed tomography, we cannot only go onto the micro or onto the nano level of a material and see what the damage is there and how the damage does develop during the loading condition. No, we do also can go further up to, let's say, a composite part, which is in use. Let's say we have a wind turbine blade or something else where we have a bolt in it and we transfer bolt into the structure. Near the bolt, we will have a stress concentration and there could be fiber fracture. So if we want to detect that, we can use X-ray tomography and just can see, okay, there is starting a damage. We see exactly the damage which had not been possible in the past. So it is a wonderful tool. And also further today, so from the presentation of Professor Takahashi or Matsuo, we had wonderful examples for the use of X-ray tomography. So here is just an idea what was on this figure, what we had far ago, how damage could develop or did develop in composite materials, now numerously verified what we expected in former times. So then to the next slide, please. Yeah, so this sums up that that we have here a damage. You see, just I put in a hole into composite material. That is what we can see, and you see here again on the right hand side, working over dimension. X-ray tomography just fits into the various dimension, and that is a wonderful and an exceptional success of technique, and it's therefore a wonderful and exceptional tool for our research work. And within this type of research, there fits very well Dr. Wang's work, and I think, and we all think, therefore, she is a good winner for our award. And the next slide, please. Yeah, okay, I give the word to Marino, and from my side, again, congratulations for this award, but Marino, you will give more details now.
Yeah, sorry, I was looking for my microphone. Okay, thanks, Carl. We can, I just taking the discussion. Sorry, I don't know what my computer is doing. Can you see my screen? I believe you are maybe seeing the double surface, but I'm passing quickly the word to Jing. Okay, sorry, do not want to spoil anything. Let me just wait a minute. Okay, come on. Come on, dear. Okay, let's keep it this way. Are you see a single page or double? Anyway, doesn't matter. Carl already anticipated the winner is King Wang. We are all happy about the decision we made. As Carl said, it was really a tough competition. We had 14 candidates, a short list of 3, which were basically very near, and then we took the final decision, and also based on the fact that the feature article written by him with the help of Serafina Garcia and Phil Withers is one of our best paper published in our journal recently. And so we decided also based on the content of the scientific activity presented by him to give the award to her. Actually, the award is in 2 parts. There is a plaque, which is that you are seeing now, which is already in the hands of him. So him, maybe you can show your. Now I just interrupted the screen sharing. So you should, if you say something, you are coming into the screen, so we can see the plaque you should have received.
Yeah, of course. Thank you so much for giving me this reward, and I'm so delighted to receive this award. I'd like to thank the award committee. As Carl and Marino said, it's a tough selection, so it's really a very happy thing for me to receive this. And thank you, David, for designing this award and sending it all the way to me in the UK, and it's really nice. Yeah.
You're very welcome. Very well deserved, Jane.
I'm seeing Carla. I don't know who is. Okay. I don't know what is now on Zoom, because it seems that. Okay, can you see the plaque from him?
I just can't see you now, Marino.
Okay, because he maybe just tried to say something, because so you can come into the game. Anyway, if you look to the sorry, but is the live issues.
Okay.
Here you are. I mean, if you look to the screen of Shine, you see the plaque. Okay, so as you have maybe seen on the slides, actually this is something the journal prepared for as a memory. But in a bit pragmatic way of scientists like to do. Plaque is wonderful to have in the office, but there is something else together with the plaque. Let me go back to the slides, which is a check of about, sorry, should be $1,000 US, which will be issued to electronically, just to be in line with the period. So the award is this nice plaque plus the check. Okay, apart from this, you see in the meantime, you have seen David Opwood, which is our journal publisher from Elsevier. Thanks, David, for joining us. I believe that now we can move to the second part of the ceremony, which is when we ask him to give a brief overview of her activity. So I can stop sharing and I invite him to share her screen and just to present a brief overview on what she did on this field. So Heen, the floor is yours for 10, 15 minutes, more or less, whatever you need.
Okay, thank you, Marina. Just let me share my screen.
Okay. Good. Sorry, Heen, just let me, before starting, because it's something I had in mind before, so if you can get back, because there was something important I was forgetting, if you can stop sharing for a while.
Yeah.
Okay, sorry, it's my fault, but actually looking into the pictures presented by Carl before, something important came to my mind. If I remember well, Carl, correct me if I'm wrong, those pictures of at the beginning of that activity was started in when Carl was doing his postdoc at Virginia Tech by Henry Schneider. And the reason why I say that is because what we are seeing when handling the papers we are receiving in the journal is that sometimes young researchers, or let's say the new generation, is sometimes forgetting what has been done in the past. There are a lot of activity is already available and is still available to the journal databases where you can really find wonderful results. So the recommendation from the board of the journal, but from everybody you can talk with in the composite communities that please, particularly for the young guys and girls, don't forget what has already been done. So when you start doing something, just try to do a very deep investigation in the literature, looking even for old works, because the pictures presented by Carla are just the first example of a deep understanding of things which are fundamental to develop modeling. And so that is what I want to say. Be careful, try to spend much more time than you need. Actually, for now is very fast and very easy to get deep investigation literature. In the past, we had to spend days into the libraries just to take the papers off from the shelf. Now it's very easy. So the recommendation again is just look back for several years. You will find something helpful for sure for your research. Okay, sorry, Hinga, go back. But that is something important I had in mind to say. I was forgetting.
That's fine. Just share.
Okay.
Okay. First of all, thank you, Carl and Moreno, for the introduction. And also, I'd like to thank the award committee and also SFC 8 conference for hosting this event and having me here. And I'm really happy to share the happiness with you all today, really. And I'm currently a postdoc working in composite materials at University of Manchester. And the topic of my talk today is understanding the damage mechanisms of composite materials by in situ X-ray imaging. And my computer seems to be a bit slow. Sorry. Yeah. So actually, I really started to learn about composite materials from the start of my PhD. And it's just 10 years ago. So I'm really happy to receive this award at the 10 years of my research career in composite materials. And I'm thankful for my supervisors who really added me into this field and also where I find the research interest in this field. And the research focus of my work has been on the damage mechanisms of composite materials. And I have been involved in a lot of research projects for a range of material systems and also for a range of loading scenarios. For example, the compressive failure of composites, the impact damage and manufacturing defects and its effect on mechanical properties, or the torsional behavior and the fatigue properties of polymer composites and metal matrix composites. But through all of these projects, X-ray imaging is the main technique I've been using to understand better the damage mechanisms of composite materials. As Carl and Moreno mentioned, X-ray imaging is not new. It has been widely used in material science for several decades. And what's really interesting to us is a material scientist always wants to know what is the material microstructure, what is the internal structure, and how does the damage look like. X-ray imaging offers us the capability to see through things. So using computed tomography, we can get the three-dimensional information of the object of the material non-destructively. So compared with two-dimensional conventional characterization techniques, X-ray imaging is really helpful for composite study since we can analyze delicate samples such as impacted composites without introducing more damage to the sample. And also, as Carl mentioned, the multi-scale characterization capability of X-ray imaging is really fantastic to understand composite materials from the fiber scale up to the component scale. And also, most importantly, we can follow the evolution over time, under load, and during degradation by using X-ray imaging. And this is enabled by the time-lapse X-ray CT that I want to present today. So X-ray CT offers us three-dimensional information, but if we add a time scale to it, we can have an extra dimension of information, which is really helpful to us to understand the material behavior from the manufacturing up to failure. So there are several types of several approaches to perform time-lapse X-ray imaging. It depends on whether we want to introduce in situ loading, and it depends on the balancing between the scan time and also the time scale of damage events. So today, I'd like to select several cases to show you how we are using time-lapse X-ray CT to understand, to study composite materials. And the first case is about compressive failure of unidirectional composites. So why do we study compression? Compression is really a classic question, a classic problem in composite study. It's because the compressive failure of composites is often 30 to 40% lower than its tensile strength. And the other fact that is compression failure is always associated with the development of kink bands, and which makes it a catastrophic instability failure, and it's difficult to characterize experimentally. As could you imagine, like at 99.9% of the failure load, just prior to failure, what will the composite look like? It turns out to really look very similar to the composite at zero load. So the deformation of the fibers is very small. So that's makes us interested to wanting to understand whether X-ray CT, the three-dimensional information, can help us to find some traces of precursors leading to the nucleation and propagation of kink bands. So that motivates us to do this study. So in terms of initiation, we managed to design an experiment to be able to load unidirectional glass fiber composite cylinders under an axial compression, and at the same time perform high-speed imaging at a rate of 1 dataset per second as with light source. And we introduced a notch to locate the damage within the imaging field of view. And in this study, as you see earlier, it's very difficult to see by eye the tiny deformation of individual fibers. So we collaborated with Technical University of Denmark and used a fiber tracking method to track individual fibers out of this volume. And you see the color lines here. Each line represents the center line of an individual fiber. In this case, we can see that all of the fibers have different orientations. And even if it's having similar colors, which means they have similar orientations, the waviness and the shape of the fibers can still be very different. This indicates the scatter in the initial fiber status. And we also look at when the fibers are deformed under load, the fiber tracks look also very different because its initial status is different. But it's amazing to find that if we look at the fiber displacement profiles, which is the deformed fiber profile deducted the initial fiber profile, we clearly see a trend, and which is really not so visible to human eyes, but we can quantify the fiber tracks and get the values out of the fiber tracks. And we can see a localized region with higher tilting angle in the displacement profile. Although it's we can even at 99.9% of the failure load, this microbuccal band is still much shallower, and the angle of the fiber is much shallower, and also the bandwidth is much narrower compared with the king band. But we did see the nucleation of fiber microbuckling from one single knee up to a localized tilting region, where we established a schematic here. So talking about initiation, we are still interested in the propagation as well. So we designed an experiment to do 4-point bending moment, to include 4-point bending moment to stabilize the king band propagation. And in this case, we managed to monitor the development of multiple king bands in the composite. And with the 3-dimensional capability of X-ray CT, we can not only see the propagation damage mechanisms in the kinking plane, we can also see the propagation mechanisms transverse to the kinking plane in the 3rd dimension. Apart from this kind of simple loading scenarios like tension compression, we also managed to do some torsional failure studies of braided composite tubes. And here shows the first in situ torsion study we did at the diamond light source on braided CFRP tubes. Before loading, we managed to look at the macrostructure of composite, the braided composite, and quantify the wavelength, the wavelength of individual fiber tails, which are really helpful for later on we study the damage and correlate the damage with the macrostructural features. And here shows the 3-dimensional damage evolution in the braided composite tubes. And the intertoe debonding and intra-toe cracking damage has been highlighted in different colors in 3D. Also, X-ray CT offers us the capability to virtually sectioning any plane that we are interested in without damaging the sample. And in our case, we are interested in the planes parallel to the fiber direction. And here shows a cross-section along the -45-degree toe. And it's interesting for us to find that in the torsional failure, the compression failure and fiber microbuckling and king band formation in the compressed toes is also the critical damage mode leading to fracture in this material. And lastly, the 3rd case, I want to mention some works we did about fatigue, since the conference is about fatigue of composite materials, and I thought this might be of interest to you guys. This is a work that we collaborated with Technical University of Denmark and LM Wind Power. So we wanted to study the fatigue damage mechanism, the tension fatigue damage mechanisms of glass fiber composite materials. And this material is mostly unidirectional material with off-axis binder yards, which are highlighted by the green color. As you can see, we employed an ex situ approach to fatigue the composite for a few thousand cycles of, and then do a scan and interrupt the fatigue testing at different stages and repeat the X-ray CT scan. So in this case, we managed to locate the actually damage initiates really in the vicinity of the crossover of binder yarns in the material, which is really helpful for us to understand the damage initiation mechanisms. And in this study, we use the helical imaging strategy, so we can image the long fiber composite at a high resolution in one go. You see the dimensions between the width and length is very large in this case. And also, apart from room temperature studies, we can also employ and introduce in the environment, the change in environment. So in this case, we used an environmental chamber to heat the sample and also apply the load at the same time. And here is a study of the damage mechanisms of titanium matrix composite materials for aeroengine applications. And by combining in situ X-ray imaging and X-ray diffraction, we can get the information of the 3-dimensional damage morphology with the strain distribution in the material, which is really helpful for us to understand the damage mechanisms. And here shows with the fatigue crack, the damage morphology near the fatigue crack tip, where we can clearly see the crack path distribution, and also like the black here is the matrix crack path, and the brown discs here are where the fiber breaks are. We can also correlate this information with the strain distribution around the crack tip. And from this strain distribution, we can also calculate the interfacial sliding stress under fatigue and see how the fatigue and the heating damages the interface and degrades the interfacial properties. And this is really helpful for the material scientists of this to design the interface and balance the properties between the fibers and matrix in this material system for longer fatigue life. So to conclude, in this talk, I really just showing you briefly about my research work, but I want to say, as Carl mentioned earlier, CSTE is really a powerful tool to provide insights into the damage initiation and propagation mechanisms of composite materials through time-lapse imaging. And also, lately, the high-speed imaging capabilities makes it possible for us to study fast events associated with the composite failures. And also, there are a lot of groups, more and more groups working on X-ray imaging of composite materials in recent years. And there has been a lot of development in hardware and software to help us apply it more efficiently to composite materials. And for future directions, I think like image-based modeling, digital volume correlation, laminography, or helical imaging are really helpful techniques and approaches for us to study composite materials in the future. And most importantly, I'd like to thank my supervisors, my colleagues, and my collaborators for their support and contribution to these works. And with their support, I can really make this work possible. And also, I hope to be able to continue contributing to composite science and technology and the composite field with high quality research works. And lastly, I want to mention that in Manchester, there is a newly founded National Research Facility on X-ray computed tomography, and there are loads of opportunities open for collaboration, both academia and for industry. So please do get in touch if you're interested in composite works and X-ray imaging. And lastly, thank you, Carl and Moreno, for arranging this, and thank the ICFC 8 conference. And thank you all for joining us today.
So, thank you very much. If you can maybe stop sharing, we'll give you an applause, even if it's virtual. Congratulations.
Thank you.
Thank you very much for the nice presentation, very I would say synthetic but very effective summary of the capabilities. I would like to ask, we are basically all here in the sense that all the participants of the conference are joining the event, and that is also nice. Actually, we concluded the previous session, as Carl was mentioning, a couple of works on the synchrotron possibility to measure the evolution of damage, even at a smaller scale. Actually, I believe that all the authors are here. If I'm asking if there is someone who wants to share views or ask something to him with taking the opportunity to have her here. And so please ask, raise your hands or just open the microphone and ask the question. In the meantime, I saw him here. Let me check if he's still with us. I would take advantage also of the fact that we have his supervisor, which is one of the leading scientists, if not the leading scientist in the world in the field, is Phil Witters. And so, Phil, maybe if you want to give a comment also on the overall application of micro-CT, you are also the most welcome to do that. In the meantime, we wait for questions from the audience. Phil, are you still here? Actually, Phil told me that he was very busy in the review of a project, so maybe he already left. I'm not seeing the full list. Okay, are there questions from the audience? If not, I have one for him, which actually is related to your very last slide, because one of the issues, particularly for people doing fatigue, which is our main business, as you know, about the using of micro CT is the fact that you have to rotate the sample either or the imaging system around the sample. Actually, you mentioned laminography at the end, which is one good opportunity in my view to have the possibility to, we can say, to investigate the damage evolution with a very limited rotation. Can you say us something more in that direction?
Actually, as you mentioned, laminography is really powerful, but the rotation axis is like off axis. So if you have an in situ rig, it's more difficult to rotate it and stabilize it for X-ray imaging, since you know the motion artifact is a very tricky thing to avoid during imaging. But as we have done some work on fatigue testing, in situ fatigue testing at Manchester as well. So what we wanted to do for fatigue is that we want to design a rig that doesn't rotate the rig itself, but it's only the grips and the sample rotates. So that's easier for us to take CT images as high resolution and high stability. But it's the rig design will be really tricky.
Yeah, the point is also if you make, if you make the system rotating, actually you can apply the usually limited load. So the idea of having two columns of the system is indeed a tricky issue. I actually hear someone getting into the discussion. Please ask again. I don't know who was speaking. No, nobody. Questions again?
Could I, Yin, could I just ask a very quick question? So this is David.
David, sorry.
Yeah, sorry. As a complete sort of layman and non-scientist in this area, could you give an example of how this kind of technique could be used, in a sort of applied way?
Actually, X-ray CT imaging has been widely used in automotive industry as well. So when the manufacturer parts and composite parts, like for the fancy supercars, they always wanted to see whether there are any manufacturing defects in it that will degrade the property. So they will do a quick scan. So we can do parts, big parts, but not so big just in line with manufacturing at factories, and to make sure the quality is okay. And also, and there are some inline X-ray imaging techniques used for detecting damage in airplanes and things also. But I think mainly the X-ray radiography, which is just one X-ray image, not the computed tomography. Yeah.
Right.
So
Okay.
there are a range of applications in the industries.
Yeah, it's really interesting. Thanks.
If I can just add a comment, we had a seminar online again a couple of weeks ago on the development of the composite arms for the America's Cup boats. The last made when Luna Rossa won the Prada Cup. And it was funny to see that they also use a big toroid for CT investigation on looking for the damage defects. In that case, the arm is something which is like, I would say 40 centimeters in size and 4 meters long. So you can really, if you design, it was basically longitudinal, so you can go through the system. So the point is always to find a balance between the size and the solution you want to have. But that is really an incredibly powerful tool. Okay, we had some discussion too. I am making the last call just to see if someone arrived and want to ask something to him. If not, as she said, you can contact her later on. Okay, so if not, thank you very much again, him, for joining us, and congratulations again for the award. David will finalize the second part after the plaque, so you will go to something more in a short time. And I will take the occasion that we are here. You see, I also changed my shirt. You see on the back, I'm speaking as an editor of composite science technology, and taking the job of my boss, which is Carl, which is listening. We can also advertise the next edition, because you know that is a biennial event. Actually, the original plan of the award was to be delivered during the ICCM conference. This year I was planned to be in Belfast, but it was postponed because of the pandemic. Actually, they postponed for 2 years, so we decided to have it online again. So the next edition will be in 2 years now, and let me get to the slides. So I would like to remind all the participants, particularly the younger one, how sorry, I need to share my screen. Okay, here we are. These are the rules. So basically, sorry, this is the beginning. I don't know why. Okay, these are the rules for the application. Actually, you will find all the information and some practical instruction for application in due time in the Composite Science Technology website. In the meantime, let me just remind you all that the participants, the candidates should be under 35 years of age at the time of nomination. And anyone in the composite community, readers, board members, authors, can nominate someone. Also, self-nominations are accepted. Of course, the requirement is to have published a paper in computer science technology as a first author in the 2 years prior to the award. So the next one will be 2023. So this means that the papers to be considered will be those of 2021 and 2022. Selection will be based on the quality, of course, of the paper and on the bibliometric the indexes, as well as on the profile of the candidate and the contribution to the composite community. So these are just a very brief reminder of the rules. Keep track on our website, and you will be informed in due time about what is needed to apply. And we really look forward for good participation. As I discussed before, we had, sorry, there are a couple of microphones open. If you can switch them off, please. Thanks. I was saying that we had already 14 candidates in this case, and it was a really tough competition. We are happy to have as many as candidates as we can, because that is helpful for promoting the capability of young people to do good research. And in this sense, let me just remind once again what I mentioned before about the previous activity. Young people tend to be a bit short in looking back. Even if the papers are dated 20 or 25 or 30 years ago, there are still wonderful work and a lot of brain inside, because the activity in the past time were forced also by the means available. I mean, I would say now the game is too easy using micro-CT, but it's much easier than looking to the X-ray macrographs made on 1D size. So there is a lot of material published. All the journals, particularly Elsevier, is providing a lot of coverage back to 85. David, correct me if I'm wrong, but it should be that day. So you find a lot of material available. So look at that. And this brings me to my last slide, which is about promoting the submission to our journal. Is one of the top in the field. I can say the top, even if I would say that, but for respect to our friends which are editing the other sister journal like Company, and so on, let's say we are among the top in the field. We are always looking for good papers, and good papers means that we are activating a quite tough selection. You know that the rejection rate is rather high. I would say 1/10 is passing roughly. This means that this doesn't mean that we are cutting everything. We are keeping only the best. And so we are looking for those papers. You see that the distribution is very nice. The paper mentioned before by Carl, published by Hina, Phil, and Serafina, is one of the best papers we have in the journal. So please check the guidelines. There are some rules we are asking to our authors to adhere with. Particularly, our ideal paper is a paper where you put some experimental work, some modeling. You combine them together in the exploring and exploiting new understanding. Anyway, the invitation is to submit your work to the journal. Then we will we'll try to provide our best for giving you good review in a short time. Okay, after a bit of advertisement, I would get back to the main reason we are here, which is celebrating the award for HIN. So thank you very much again. I will pass the word to Carl for closing the session, and I thank you very much for joining us for this. Carl, the floor is yours again. You are muted. So let's see if we can get Carl back.
Yeah, okay, now I'm back. Okay, thank you very much, Marino. Everything well done. And looking for good papers for our journal, and what we want to promote also good scientists, and we would be a forum for discussion in our journal for good science on composite materials. And so we are looking for the next years. In 2 years, I think, yes, then there will be the next award, and we will see on what subject it will be and who will be the winner of that award. So thank you, and thank you for organizing it. Thank you.
Thank you. Thank you, Carl.
Thanks, everyone.
Oh, sorry, David, please go on if you want.
No, just to say thank you very much, Marino, for your diligence in organising this session, and great that, you know, we've been able to do this alongside your conference. I know people have really struggled with the pandemic, with various conferences being cancelled. So I actually think this has been a really, really nice forum to do this. So just thanks to you and to Carl, and again, congratulations to Ying. It's great to hear about your research. I found it really, really interesting. So yeah, thanks everyone for attending.
Okay, so thank you, David, for the closing. I believe that we can close the session. We are perfectly in time. So once again, thank you everybody for joining us, for celebrating the award to HIN. And we really look forward to receive your work for the journal. Okay, getting back now, I change my shirt again. I get back to my institutional one. So I'm still on my capacity of the chairman of the conference. That you see on the back, by the way, for those of you who don't know, is the anatomic theater we had in the main building of University of Padua. Is